All right, welcome back to your favorite intermediate algebra class. Today we're going to look at graphing and solving quadratic inequalities. Okay, so we're going to go ahead and graph those and solve those as well algebraically. So let's look at the graphical portion of this first, where you've got something like y less than or equal to, let's take negative x squared plus x plus 5, okay? So when we did this, now we have graphed quadratics as y equals, like a y equals negative x squared plus x plus 5, and that's where actually you want to begin with these ones, is you want to do that boundary line for this, we call it. We want to graph a boundary line. So we, for a minute, we imagine this to be y equals, okay? If you remember when we did that, we did an axis of symmetry first. So x equals negative b over 2a, okay? Which in this case ends up being your b is 1, your a is negative 1. So this is negative 1 over negative 2. So x is a half. For this one is your boundary line, okay? And then the second thing is when you're graphing this boundary line, you want to look at this inequality, okay? You want to think about, on this boundary line, am I including the points on there or not? And if it's got one of these two signs, you're going to make that boundary line solid. But if it's one of these two, you know, a strictly less than or strictly greater than, you want to dash that boundary line when you do go ahead and draw the thing, okay? So when you do go ahead and draw this. So here we go. Let's go ahead and finish this one here. All right, so we got this vertex, which happens to be right there at 1/2. We need to find the y value for that. So we go ahead, square the top, square the bottom. So you got negative 1/4. Get a common denominator here. So change that to 2/4. And change this to 20/4. All right, so we got negative 1/4 plus 2/4 plus 20/4. So we got 1/4 plus 20/4, or 21/4, which is 5 1/4. All right, so 5 1/4. Well, I didn't pick the greatest problem here, did I? So we have this boundary line. If this is x equals 1, we got the boundary line, or I'm sorry, the axis of symmetry right down there. X equals a half. We have now our vertex is a half, comma, 5 1/4. So 5 1/4, about right there. There's our vertex. And we know this thing opens down because our a is negative 1. So this is going to open down. So I'm going to go ahead and pick, like, let me go to the left of this. Let me go to the left, so go 0. How about negative 1? I'm going to plug those two in. When I plug in 0, it spits out 5. When I plug in negative 1, looks like it's going to spit out 3. Let me go to the right now. When I spit out, or punch in something to the right, like 1, and then maybe 2. Okay, 1 is going to spit out 5, 2 is going to spit out 3, because this thing is symmetrical, right? That's the behavior of these quadratics. So 0, comma 5, negative 1, comma 3, 1, comma 5, 2, comma 3, and you can kind of graph this. Now we got to make sure this thing is solid. Okay, we graphed our boundary line. It is solid. Graph boundary line as solid. And again, why is that? Because right there, you have a less than or equal to, right? Which means it's got to be solid. In other words, all these points on this solid line I just drew, this boundary line, any of these points on here make it true. Make it true if I plug them back into here. Okay. Now we have to shade. That's step 2. Okay. We've only done, what we've really done up to this point is we've only graphed the quadratic equation. We've only graphed this, the quadratic equation, which we call the boundary line. The question is, where do we shade? Where do we shade? So, step 2 is you simply test a point either inside, go back up to this, either somewhere inside here or somewhere clearly outside. But it cannot be on the boundary line. Okay, you have to test clearly inside or clearly outside. Well, you guys know that I like to test easy points. Like, how about that one right inside? I'm going to test 0, 0 on the inside, since again, it's clearly not on the boundary line. And I'm plugging it into this, and I'm going to see if it's true. Okay, so x, y. So 0 is my y, 0 is my x. Is 0 less than or equal to 5? And I say, sure, true. That means that we shade where that point is. In other words, inside, because I picked it inside. It was true. It's very similar to those quadratic inequalities that we were doing. Or I'm sorry, those linear inequalities, right? So if it's true, and it was right here, and it's true, we say, oh, that means all these points are solutions. Like if I was to pick 1, 1 and plug it in to the original quadratic, it'd be true. On the other hand, if I picked like 4, 1, this would give me false, right? It would not work because that is not a solution. That point is not a solution. Okay, so that's how you do that. You graph the boundary line, just like you guys did before in section 1. Okay, so you let it be equal to, graph the quadratic, and that's either going to be solid or dashed. Okay, we did a solid one in this case. And then you pick a point, either inside or outside, and you test it. If it's true, you shade where the point is. If it's false, like had been 0, 0 false, I would have shaded on the other side of that boundary line. Okay? So here's a couple more. Let's say you have a system now, a system of quadratic inequality. So let's graph this system, meaning 2 or more. Okay, graph this system. All right, let's say we take a look at and let's say we're graphing this as our other one. Y is greater than x squared minus 3. Okay. All right, let's do this one first, right there. Okay. Number 1. So again, we're doing this one right there. Negative x squared minus 3x plus 1. So we're going to graph y equals negative x squared minus 3x plus 1. Is this going to be solid or dashed? I say I look right there. It's or equal to, so as a solid boundary line. As a solid boundary line, okay? So I do my old axis of symmetry first, negative b over 2a. So we have 3 over negative 2, so x equals negative 3 halves. So that's going to be my x value for my vertex, negative 3 over 2, right? And then I plug that in. Negative 3 over 2. Let's go ahead and get a common denominator. And we got 9/4 from those two plus 4/4. We got 13/4. 13/4. We gotta extend this a little bit. Or 3 1/4, right? 3 1/4. Alright, let's go to this. Let's go to this graph now. I got -3/2, or -1.5, comma 3 1/4. -1.5, I'm up 3 1/4. So right there's my vertex. I know this thing is going to go down. I keep plugging in some points, like let's go to the left. Let's go -2, -3. Now let's go to the right. -1, 0. And we plug those in one by one. So you plug in, let's see here, we're plugging in -2 first. Looks like we get, I won't write them out every whole thing. 3, plug in the -3, you get 1. Of course, you plug in -1, you get 3. Plug in 0, and you get 1, right? So you plug all those points in, just like we did with that -3/2 here, right? One by one. -2, 3, -3, 1, 1, 3, 0, 1. Okay. Again, this is solid. This is a solid line. Now we pick a point. Clearly, one side or the other, right? So this is part number 2. Let's go down here. So I am number 2. I am testing. I have to test a point. So let's test. Let's go back up to this and look at this for a minute. I'm kind of unsure about this 0, 0, how accurate I am, right? Why don't I pick something a little more clear? How about -1, 1? Why don't I test something right there? So -1, 1, just inside there. That's what I'm testing. -1, comma 1. So I go ahead and I write the original quadratic. Y is less than or equal to -x squared minus 3x plus 1. I plug in y, 1, plug in x, -1. Okay. Looks like we got 1 less than or equal to 3. That's true. So we shade where the point is at. Okay, we shade where that point is at. So let's go back up. Let's shade it, and I'm like, hey, the point's right here. That means I shade all this inside, don't I? All this stuff on the inside there. Okay? So that is graphing that first blue one. Okay? Now let's go ahead and graph y is greater than x squared minus 3. Y is greater than x squared minus 3. Hope you don't mind. I'm just going to erase this stuff. Okay, so y is greater than x squared minus 3. So, number 1, graph boundary line y equals x squared minus 3 as, is this solid or dashed? It's just greater than, so it's dashed, as dashed. Now, notice when you do x equals negative b over 2a, this is ax squared. There's no bx term, is there?